Hello.
Oi.
No, you're funny.
Define the mole as a basic unit of measurement in chemical equations and its origins. A little history lesson for y'all.
Oh, here we go.
Mm-hmm.
What a mole is.
What
And then
is it?
Explain the relationship between energy and bond formation. That might be an artifact from last year.
Oops.
Sorry about that.
Oops.
Let's get into the history. It's your boy.
Amadeo Avogadro. Yeah. He figured out that quote unquote equal volumes of gas at the same temperature have the same number of molecules. Okay. And what's this mean? Well, hydrogen in a balloon that's the same exact size and temperature as oxygen in a balloon that's the same exact size and temperature would have the same number of molecules in them.
Amazing.
This size of this stuff at that temperature equals this size of that stuff at that temperature. They must have the same number of molecules.
We are not going to get into all of the experiments he did to prove this, and honestly, it might even have come up after his passing.
It did.
But nonetheless, we're going to go over it. So
we use it for something else, though.
True. So the mole is used to compute the results of a chemical reaction. It allows us chemists to determine the amount of a substance needed to start and accurately predict how much we're going to get out.
Mm-hmm.
So if you want to make something with, say, gold or
aluminum
or silver, something that's precious, you don't want to be wasting it.
No.
You want to be able to know that, I'm supposed to make 65 grams of this stuff. And if all of a sudden you made 40 grams of that stuff,
something's up.
Yeah, something's up, and you lose the money.
Mm-hmm. It is related to the volume of gas. So 1 mole of any gas, doesn't matter what atoms or make up that molecule that is the gas.
Yes.
At standard temperature and pressure,
STP.
0 degrees Celsius in 1 atmosphere.
Correct.
Will occupy, by definition, 22.4 liters of space.
Right. So 1 mole of carbon dioxide, 22.4 liters.
1 mole of H2, 22.4 liters.
You got to know that number. That is a conversion piece that we will use less than the others, but we will still use it.
1 mole of leftover lunch, 22.4 liters.
Gross.
It's true, though.
But listen, that number is also not in your reference tables.
Nope.
So you got to know that number, or you're going to miss out on some points. So you could be okay. 1 mole of any element equals its atomic mass. So here's the trick. This is the most important part of the video. What is the atomic mass of carbon, mister?
12.001.
So guess what? 12 grams is 1 mole.
Easiest conversion you're ever going to do. Memorize that 1 mole of an element is equal to the atomic mass of that element reported on the periodic table.
And guess what? We're probably still going to do the rounding.
Yeah, probably.
So relax.
So there you go.
But this is the way we can count. I know now that, see that big old number? 6.02. Oh my God.
602 sextillion or something like that.
Do you have any
it's
idea
ridiculous.
that number is so large that our brains can't comprehend? And I think I read right, if we were to have that many basketballs and line them up in a single line, it would wrap the planet like 14 times.
More like 14 billion times.
Well, I don't know about that.
If I had that many pennies, 1 cent pieces, I would have enough dollars to give everybody on this planet $1 trillion. It's just ridiculous. A mole of lithium is going to equal its atomic mass.
Well, it's almost
6.94 grams.
That's
7 grams.
That's
it.
Sweet. Mm-hmm. And a mole of nitrogen.
14. Yeah, there we go.
We're getting good at this.
So by definition, a mole is equal to the atomic mass.
Yes. There's the trick of the whole unit, by the way. Mm-hmm. So get that.
It's simply a counting number.
Yeah, I say a dozen, you say
12.
Now that one's easier for you because we can comprehend 12. Just don't fight this number. It's just a huge number.
And so we say 1 mole.
It's so much easier.
That's it.
So
number Avogadro equals 6.02 times 10 to the 23rd particles equals 22.4 liters of gas at STP equals 1 mole.
Right. So if we say we have a mole of something, all of those things are in play, which is good.
Which we'll use as conversion factors later on.
Yes. And so why it's so useful. It provides us a pathway to counting atoms and molecules. We cannot see these atoms.
But we can weigh them.
But we can mass them. Absolutely. We can
right. Weight and mass are different.
It's okay. Whatever. Chemical reactions happen in these simple whole number ratios now. These whole number ratios are these moles. Mm-hmm. So instead of saying 6.02 times 10 to the 23rd molecules react with 6.02 times 10 to the 23rd molecules, that's saying too much.
1 mole.
1 mole
reacts with 1 mole.
With 1 mole.
Boom, simple boom. Whole number ratio.
It's a lot
it actually
easier.
Makes the math simpler.
Yes. Because we're not going to ask you to do a lot with that 6.02 times 10 to the 23rd.
Nope.
We just need you to know it exists.
That's all, folks.
Time
To click the button and turn it off. Yeah.
There you go.
Ooh, yeah.